In this lesson, we are going to develop some formulas to find the derivative of functions in easier way. Our goal is finding the slope of the tangent line or instantaneous rate of change of a function in a very efficient way. In our previous lessons, we defined derivative as limit of f of x plus h minus f of x over h as h approaches 0. We called it first principle or the limit definition of the derivative. The geometric meaning of derivative at a point is the slope of the tangent line to the graph of the function at that point. And the physical meaning of derivative is the instantaneous rate of change of the function at that point. Finding the derivative of a function using first principles could be lengthy and in some cases almost impossible. That's why we work on some basic functions and we put them together to have some formulas to calculate the derivative of functions. The first formula is saying derivative of a constant function is 0. Geometric meaning of this is very clear. The graph of f of x equals constant is horizontal line. The slope of tangent line to the graph of the function at any point is 0 since the tangent line at any point is horizontal. Algebraically, we know f of x plus h minus f of x is 0. Therefore, the limit of f of x plus h over h as h approaches 0 is 0. Derivative of a linear function f of x equals mx plus b can be found algebraically using the definition of the derivative, limit of m times x plus h plus b minus mx minus b over h as h approaches 0. If we collect the like terms on the numerator of this fraction, we have mh, therefore the limit would be m. This means derivative of f of x equals mx plus b is m. Or we can summarize it by saying derivative of mx plus b is m. Geometrically, the slope of the tangent line at any point to the graph of the function and the slope of the line are the same because tangent line at any point is the line itself. Derivative of f of x equals x to the power of n when n is a natural number. Is limit of x plus h to the power of n minus xn over h as h approaches 0. If we expand the numerator using binomial theorem and cross xn and xn by dividing both numerator and the denominator by h, the derivative would be limit of nx to the power of n minus 1 plus n times n minus 1 divided by 2 times x to the power of n minus 2h plus all the terms contains h and the last term is h to the power of n minus 1. As h approaches 0, this limit is nx to the power of n minus 1 since the limit of the terms after the first one are 0. What we've done so far can be summarized in this table. Derivative of a constant function is 0. Derivative of a linear function is the slope of the function, and the derivative of x to the power of n is n times x to the power of n minus 1. Derivative of addition of two functions is addition of their derivatives, or derivative of the subtraction is subtraction of derivatives. This can be done using the definition of derivative and using the fact that the limit of addition of two functions or subtraction of two functions is equal to addition of limits or subtraction of the limits. Similarly, if we use the limit of a constant times a function, we can prove limit of c f of x is c times f prime of x. This is called constant rule, and basically it says derivative of a constant times a function is that constant times derivative of the function. Let's have some examples. Derivative of c times x to the power of n. C is a constant. The derivative would be c times derivative of xn, which is c times n times x to the power of n minus 1. I used derivative of c times f of x equals c times derivative of f of x. Derivative of y equals 5x plus 2. It's a linear function. Derivative of a linear function is a slope. In this case, derivative is 5. Derivative of y equals 9x to the power of 7. If we use the fact that the derivative of c x to the power of n is cn x to the power of n minus 1, then the derivative would be 63 x to the power of 6. Derivative of 8x5 plus 2x3 is 4dx4, the derivative of the first term, plus the derivative of the second term, 6x2. Using the fact that the derivative of addition of two functions is addition of derivatives. Derivative of 9x4 plus 6x5 minus 4x3. Derivative of 9x4 is 4 times 9, 36, x to the power of 3. Derivative of 6x5 is 6 times 5, 30, x to the power of 4. And derivative of 4x3 is 12x2. Derivative of addition of two functions is addition of derivatives, and derivative of subtraction of two functions is subtractions of derivatives. Let's recap. In this lesson, we developed some formulas, and we used them to find the derivative of functions to avoid the lengthy process of finding the derivative using the first principle. Thank you.